Hello, Algebra 2 students. Today is quadratic applications practice. So nothing new, just one of kind of each type of question that we have done. So the very first one here is talking about quadratic regressions and debris falling off a cliff. I think we have talked about a question that was similar to this. And so the first thing you have to do is put it into your calculator. So you have to go to Stat, Edit, and then type in the time after the debris has been dropped, and then the height at those given times. So this has to be L1 and L2. Right? So when you go to Stat and then Edit, this is where you would then type it in. All right, I already have mine in here. So just double check once you type it in, make sure it's looking good, and then let's do it. So running a quadratic regression is like running any other regression. You are going to go to Stat, and then go over to calculate. So that's what these directions are here. Stat, you go over to calculate. Oops. And then choice 5 is a quadratic regression. So it'll default to list 1 and list 2, and then just run to calculate. So that's the answer we should end up with here. So state the regression to the nearest hundredth. So we're going to go with in this format is what it's telling you. We have negative 19.14 x squared. B is 17.6 exactly, so plus 17.6 x. And then C is plus 861.14. All right. So it says use the regression, find the approximate height, rounded to the nearest foot of the debris at time equals 7 seconds. Let's change that. Let's make it 6 seconds here. Right? And so then all we'd have to do is plug in t equals 6, or I should say, based on the way I wrote it, x equals 6. But this really should have been back here, h, and then these should be t's. So same difference, not a big deal, but just want to try to make sure to connect it to the question here. All right, so if we plug in, we're going to have negative 19.14 and then 6 squared plus 17.6 times 6 plus 861.14. All right, absolutely. Let your calculator do the work. So times 6 squared and then plus 17.6 times 6 and then plus 861.14. All right, I'm coming out with 277.7, which if we think about that, it says find the height to the nearest foot. Let's round it first. So about 278 feet off the ground. We'll come back up and look at the chart. At 6 seconds, being at 278 seems fairly reasonable. It's not going to, necessarily have hit the ground yet, but it's getting closer, right? So it started at a height of 875. It's down to 278 at that point. When it says predict at what time it's going to hit the ground, all right, when it hits the ground, that means the height is equal to 0. And so we'd have to plug in a 0 on the left-hand side of that equation. And solve. You can do this algebraically with quadratic formula. You can do it graphically by making this y1, y2, and then solving from there, right? So either way will work perfectly fine. Quadratic formula might be a touch messy, but it will work. So what I would maybe do in this case is to do it graphically, but just know that those are the options. For right now, I'm going to move on to the next question. We can talk about that guy in class. All right, for number 2, use the given info to make a sketch of the parabola, the focus, the vertex, and the directrix. All right, and then determine the equation of the parabola in standard form. We really haven't done much of that, but we'll at least talk about what that is. That is not super important to me, just FYI. So we have our focus at 0, 2. So 0, 2, there's our focus. The directrix at x equals negative 2. So negative 2 on your x-axis. It's that vertical line right there. That means my vertex halfway between has to be right here. And so that's at negative 1, 2. And right now, it's going to wrap around the focus. So it's going to open to the right. All right, a couple of things. That means that it's an x and a y squared problem. So the fact that it opens to the right means you got y minus k squared equals 4p and then x minus h. Here's the h in the k. The other value you need is p. The fact that it opens right means p is positive, and that little distance right there is just 1. So it's a positive 1. So now you can plug in all the values you need. So we've got y minus 2 squared. 4 times 1 will just be 4. And then x minus negative 1 will turn into x plus 1. So there's the equation in focused directrix form, or the locus definition form. The parabola itself, I would have to continue by plotting 2p. So that's going to be a distance of 2 above the focus, 2 below the focus, so that I get a full sketch. But now when it says write the equation in standard form is when we say y equals ax squared plus bx plus c. This particular one's a little different because it's a y squared problem. So what I really mean in this case is that would be x equaling ay squared plus by plus c. Definitely a little funky to read. How we would do it, though, just for the sake of talking it out, would be to get the x all by itself. So if I want to get this x completely alone and get everything else distributed out, you would actually have to square this. So y minus 2, which would give me y squared. If I FOIL, because I don't want to have to show box method, outsides would be minus 2y, insides is minus 2y for a total minus 4y. Last would be plus 4. If you like box method, that's fine. Right over here, let's see, what's that going to give me? I'm going to distribute the 4. So distribute the 4, that'll give me 4x plus 4. And then I would start rearranging. I could subtract the 4 over, which actually cancels it right out in this case. So I get 4x and then equals y squared minus 4y. And then last step would be to divide everything by 4. So x would end up being, that would be 1/4 y squared. And then here the 4's would cancel, minus y. This is standard form. So same parabola, just writing it a different way. So this is locus definition, or it can also be called focused directrix form. All right, there you go. That's why it's not that big of a deal, because it's the same darn parabola. You're just writing the equation in 2 different ways. So flip it on over to the next page. So page 20 in your packet. So this one, when we go to do it, I'm not going to worry about getting it into standard form. If you're curious, I can always put my answer up and you can go for it, but otherwise I wouldn't stress too much about it. All right. So same thing, get the focus down. So -1, 1. The directrix y equals 5. So 1, 2, 3, 4, 5. So right off the bat, I know my vertex is halfway between those. So if it's a distance of 1, 2, 3, 4, I'm going halfway to 2. So that's the point -1, 3. That tells me my parabola opens down because it's going to hug the focus. So because it opens down, that means that it's going to be x being squared and then 4p y minus k. So it's more like a typical parabola. All right. What else do I need to know? The p-value, that distance right there, p is 2. And because it opens down, p is going to be -2. All right. Let's start plugging things in. So h, k. So x minus -1 turns into x plus 1 squared. 4 times -2 is -8. And then y minus 3. All right, over here, the only other thing I would need, 2p is equal to -4. So all I care about is the absolute value of that. If I go left 1, 2, 3, 4, and go right 1, 2, 3, 4. All right. There I have it. If you want to try to challenge yourself and solve this and get it into standard form, it should read at the end as y equals -1/8 x squared minus 1/4 x plus 23/8. It's not that pretty. All right, 23 divided by 8. If you think about what that is, 24 divided by 8 would be 3. So that's just shy of 3. That's your y-intercept. Come look at our graph. 1, 2, 3. Yeah, just shy of 3 makes sense right there. So even if you're like, this looks crazy, even without a calculator, you can kind of confirm that, yep, it's opening down. That should be negative. There's my y-intercept. Couple things you can kind of check on. All right. To graph it, maybe we'll save this one for class. That's a good one, easy one to start class with. All right, you have 2 left. The 2 that are left, you've got a little multiple choice. So what's the equation given all of this? I'm actually going to have you try this one on your own. And then there's a little video question for you. Yay. You don't have to actually write that down. You just have to do it. Okay, last one that we're going to do together. Graph the system, determine the solution graphically, and confirm it algebraically. All right, we're going back to the first days of the unit. When x is squared and y is squared. That's how I know it's a circle. When neither x or y is squared. That's how I know it's a line. All right, so this is a circle where the center is 0, 0. R squared is 4. So the radius is 2. So at 0, 0, you're going to go right 2, up 2, left 2, down 2, and do the best you can to draw that circle in. And then your line, just change that into y equals mx plus b form. So subtract the x on over. That's going to give me negative x minus 2. And so I know that my slope then is negative 1. My y-intercept is down here at negative 2. So then down 1, right 1, or more importantly, up 1, left 1. So look at these nice pretty values where they're crossing. I think I have a straight edge floating around in here. Yeah, there we go. That'll work. All right, that could have been nicer, but I tried. Okay, based on this, I have 2 solutions. So my 2 solutions should be, let's see, this is negative 2, 0. And then this is 0, negative 2. Okay, to show this algebraically, because you know you're going to see this on the test, you would have to take and do a little substitution. So what I'd probably want to do here is I would want to take this guy right here, since it's already solved for y, and let's plug it into the other equation in place of y. So we're going to do a little substitution here. So we'd have x squared in for y, negative x minus 2 squared equals 4. So it's a little messy, but now we have everything with just x's. So this you do have to multiply out. You can write it twice in FOIL. You can box method. Since I already did it once by FOIL, maybe I'll do this one by box and make sure that, make everybody happy here. All right. So this would give me positive x squared. This would give me positive 2x. Positive 2x, and positive 4. So all those negatives cancel themselves right on out. Okay, bring down your x squared. From all of this, we then have x squared plus 4x plus 4, and then equals 4, because you're just bringing that on down. All right, combine your like terms. We have 2x squared plus 4x. I'm going to, at the same time, move that 4 on over. So when I subtract it over, it actually just cancels right out. So I come out with this. Don't forget, when you're solving, you're looking to hopefully factor, and if you can, take out a GCF first. 2x can be divided out of each. You're left with x plus 2. And then right here, set that equal to 0. You get x equal to 0. Set this equal to 0. You get negative 2. There's my x values. And then what we would do is plug back in to get the corresponding y values. You can plug into either equation. I would always suggest the linear one because it's easier. So over here, because I'm out of space, if I plug in 0 to my linear equation, I just get negative 2. So 0, negative 2, there's my one solution. Plug in negative 2 to the other equation, or to the linear equation, you would get negative of negative 2, which really means positive 2. That's going to give me 0. And so then that you can see there's the second solution right there, and done. All right, thanks guys for staying with me. See you soon for some review.